This is Mastering Mathematics with your teacher, Karen Weston.
Hello Antigua, Barbuda and the rest of the world. Welcome again to another in the series, Mastering Mathematics, a program sponsored by the Ministry of Education using its ABE unit, Center for Mathematics Education, and of course ABS Television. We aim to bring mathematics right into your doorsteps, into your bedrooms, all over, anywhere you are, on the high seas, on the road, because we are all going to be mathematicians in this country. And we make no apology, we're teaching to an examination, because we are going to pass that maths exam. And from there, we will take the nation by storm. What have we been doing? Yes, I said we were peeping, we're listening to the children. What are they doing in school? Most of them are touching that topic, matrices. So we are jumping on the bandwagon because we have done our groundwork in terms of setting foundations for the foundational aspect of mathematics, the laws, the operations, etc. Last time we left you where we were actually showing you one of these operations, which was indeed the multiplication of matrices. What do we know so far about the topic? We know, for example, we have done our definition. So we have done our definition. We know how to find the order of the matrix. We know how to get the operations. And we know the different types of matrices. In our operations, we're talking about, so here, we're talking about addition, we're talking about multiplication, and this involves scalar and matrix multiplication. Our concern, and once we get into addition, we know subtraction follows right here too. Subtraction. Right. Now listen, because exactly what I'm talking, I'm writing on the board. So I spoke about addition, subtraction, multiplication, showing that we have two types of multiplication. The first type is the scalar, which we said follow the distributive law, meaning everything outside of the bracket is multiplied by what's inside, okay? Or everything inside the bracket is multiplied by the number or the letter outside. And the letter or number outside is what we're calling the scalar. And then we have a special type of multiplication, which is unique only to our matrix topic. And let us just remind you, because it's going to come into play again. And so we said, because in the order, we say it's the number of rows times the column, which will tell us how big or how little or how small that matrix is. Okay? And we know right away for our definition that we have said that a matrix, it is an array of numbers. And we have told you where we're using them in our environment. So for those of us who go and pick fruits or have the different brands of meat, or we are sorting them, which one is A, which is B, which is on what shelf, okay? And then we told you that we use that matrix in terms of sorting letters, of setting out suburb, of using it in terms of even in the supermarket, what we're calling aisles, etc., would be rows and our columns and the whole principle. And then asked you to Google for yourself some of the areas in the real world where we would be using matrices. For us right now in the school compound, we are using it to solve a simultaneous equation. So this whole charade, what we're trying to teach our students in school in terms of the matrix topic is to eventually lead them to use it to solve a simultaneous equation. and that is where I'm taking you. Before that, let us just recall, if we have a matrix A and it's equal to 2, 3, 1, 4, and matrix B, which is equal to 5, 6, 7, 8. I'm using positive numbers just because I want to emphasize the concept more than the whole algorithm associated with working numbers, okay? But we do use negative numbers. But then this is just to hammer home a concept. If I want to find A, B, which means the silent operation there is multiplication, we would then be saying it is our 2, 3, it is our 1, 4, and it is times our 5, 6, and our 7, 8. What do we know? We know that from the first matrix, we'd be getting all of our rows. All of the rows would come here. And just not to confuse ourselves, we put them in a little box like this, okay? Until we can go fast with it, so that we know. So the 2, 3 would represent our first row, and we said the first row must be used up with each of the columns, okay, in the second matrix, with each of the columns in the second matrix. So what am I saying? The first matrix provides us with all of our rows. The second matrix provides us with all of our columns. How do we achieve our multiplication task? What do we say? We say the same thing as if we were adding the numbers or subtracting them. The things in the same positions are multiplied together. So here we go. This would now be, and don't forget to put them back in their bracket, it is 2 times 5, first with first, plus 3 times 7. 3 times 7. Yes, so we are looking, okay, because we have to start teaching our students in school. They have to pay attention. They have to listen to the teacher. The teacher cannot be faulted if she's teaching and then somebody else is just sitting in the classroom and talking about something that happened last night, or they just remembered, or they saw on the television. And too much of this is happening with our students. We have got to make them single-minded. I see that in my classes at my yard. Students are here and I'm teaching so gloriously, and all they're doing, talking about something or trying to answer. Can you imagine? Answer a cell phone. How can this be? And then we stay outside and criticize teachers for not wanting to bring them on the compound. Parents, we have a task to tell our students when and where what is appropriate. All right? And in the academic world, it is important that we are single-minded, and whatever we're doing at a specific moment, that should be the only thing occupying our minds. That should be the only thing occupying our minds. So here is just the cameraman and what I'm saying in terms of teaching you something. The rest of the world can wait. All right, so here we go. It is 2 times 5. 2 times 5, we're looking, plus 3 times 7. All right, so we have taken care of first row with first column. Secondly, we have the first row again, 2 times 6. So it is 2 times 6, and it is plus 3 times 8. 3 times 8. So we would have completed using up our first row. Take it slowly, because if you know it, you don't have to repeat it again. It is 2 times 5 plus 3 times 7. 2 times 6 plus 3 times 8. Then we go 1 times 5 plus 4 times 7. And then it is 1 times 6 plus 4 times 8. And we just do a little 2 5s, 10, and it is plus 21, 12, and it is plus 24, and it is 5, and it is plus 28, and it is 6, and it is plus 32. And so we have, it is 31, and it is 36, and it is 33, and it is 38. Just doing the addition, and that is the answer. Alright, so we just recall, we're juggling our brains. We know already the scale is just multiplying what is outside the bracket by what is inside. This technique is going to be important. I'm sending you on a little break, and then I'm taking you exactly where and why we're introducing this topic in the mathematics classroom for an examination situation to help solve our simultaneous equation. Take your break and see you in a minute.
Don't look on what I cannot do. Focus on what I can do. I may not say what I do, but I can hear a feeling I strongly.
I may not hear, but that does not and should not affect my ability to learn and to function in the real world.
I am a gifted student. I need the opportunity to soar. Support me in my climb to higher levels of learning.
Some of our children have special educational needs. They have a right to an education. So, let us teach them the way that they learn and help them to achieve their full potential.
Be sure that you're working in the same units of measure when performing calculations. If a problem involves inches, feet, and yards, be sure to make the appropriate conversions so all of your values are in the same unit of measure. For example, change all values to feet. When asked to show work or justify your answer, don't be lazy. Write down everything about the problem, including the work you did on your calculator. Include diagrams, calculations, equations, and explanations written in complete sentences. Now is the time to show off what you really can do with this problem.
Alright, you're back. Yes, and we had our break and now we are ready and we're taking off. Alright, one thing only we're concentrating on. How do we use matrices to solve any given simultaneous equation? I have 3 on the board because we're going to do something first. Let us look at the first one that we have. And the first one we're going to look at is 8x, and it is plus 3y is equal to 2. That's equation number 1. And it is 5x, and it is plus 4y is equal to negative 3. So we're now introducing a second method in what we are saying, how can we use matrices to solve simultaneous equation. You know, before we were doing the elimination process, etc. for the first section. In the second section, you'll be asked to use a matrix method to solve the given simultaneous equation or parts of it. All right? what do we have to do? Involved in this process is our constructing 3 types of matrices. So our first task number 1, identify 3 matrices. Because if you ask me to use a matrix method, I have to get them dressed as persons who can look the part. Okay? So 3 matrices. Where are they going to come from? Our first matrix, this represents all the coefficients of the variables. And of course, we know the variables are our, in this case, x and y's. Okay? So all the coefficients, so the first matrix will be made from all the coefficients of the variables. And by that, I mean the numbers, okay, in front of the letters. So what am I saying? In terms of child's play, the first matrix would be as if it came along, erase the x's. Oh, sorry, taking up the wrong thing here. So this is 3. Okay, erase the y's. Okay, and forget this side of our equal side. And so that would be our first matrix, a 2 by 2 matrix, which is made up of the numbers 8, 3, 5, and 4. So we have a 2 by 2 matrix, all right? And it is made up from the numbers 8, 3, 5, and 4, because we had 8x, and it is plus 3y. So this was 8x plus 3y, 5x plus 4y. So when we take out the x's and the y's, we are just left with the numbers 8, 3, 5, and 4. That's the first matrix. The second matrix, this is a column matrix made from the variables. And here these are the x and the y's. So it's a column matrix. So in our case, and as they occur first, the x goes on top and the y at the bottom, and that is the second matrix that we are forming. Okay, so our first matrix comes from all the coefficients of the letters. So you have 8, 3, 5, 4. The second matrix would tell us what were the variables we're using, x's and y's. And just as they appear, the x first row, the y second row, all right? And it's not because it's on second line, it's in the position. The first one we meet is the x, so that's why the x is written first. And then our third matrix would come from these guys after the equal sign, the constant terms, I'm calling them, who are screaming and saying we want to be enclosed in curved brackets too. So the third matrix is also a column matrix. So the third matrix, that is a column matrix of the numbers after the equal signs. So that those numbers in our case here would be 2 and -3. And again, a column matrix. Alright? So that is the first task in terms of setting up our simultaneous equation to use a matrix method to solve it. And the matrix method I am using is the inverse method. Alright, so I am using the inverse method because we can use a diagonalized method too. But I am concerned with the inverse method because it has several parts which lends itself nicely for CXC to ask the types of question we are looking for. Alright, so again, what do we do when we're finished? Having identified the 3 matrices, I'm going to erase the task that we said because you now have those etched in your book and on your braids. Task number 1, get the coefficient of the variables and we write it as a 2 by 2 matrix. Task number 2, we write the matrix as a column, the variables as a column matrix. And then task number 3 is writing the constant terms as a column matrix. We must now join them. And how do we do that? It is then given that we're going to call, if we have matrix A for the first one, times the second matrix is equal to B. That is what the statement would look like. First matrix, and we're calling it A, times second matrix, X, is equal to the third matrix on that side over there, which is called B. So we would have been writing then that it would have been 8, 3, 5, 4, and it is times XY is equal to, and it is 2, -3. That is the first step that you have in solving your simultaneous equation. And do you know that that is the first question you can be asked and the only part of a question in the matrix section? And last year, June, they had it. They said, given the simultaneous equation, write it in the form AX is equal to B. And all the students had to do was to remember your 2 by 2 matrix times your variable is equal to the numbers on the other side. 2 marks for that. Alright. Yes, it is as easy as that. So we have given you your first step in terms of using the inverse method to solve a simultaneous equation. I have several equations here on the board, and I'm going to call them quickly because I'm sending you home to see if you can do this. Spend the night writing it in this form, and is 5x plus 3y is equal to -7. 3x plus 4y is equal to 0. Let me call it out again. It is 5x plus 3y is equal to -7, and 3x plus 4y is equal to 0. I want you to write it in this form. AX is equal to B. Construct the 3 matrices, put them together because you're getting ready to solve a simultaneous equation. Secondly, to show that you can write it in that form, I want you to try this other one, which is 3x plus 2y is equal to 1. 3x plus 2y is equal to 1. And x plus 4y is equal to -3. x plus 4y is equal to negative 3. So we are on our journey, and we have started the task of using matrices to solve simultaneous equation. And you can teach somebody already that, right, the first thing is for us to transform the matrix into the category that would make it a matrix method ready equation. So we have to transform it into that form. If we're a policeman, you have to dress like a policeman. If you're a teacher, you should dress like a teacher. If you're a person, dress like a person. You want to use the matrix method, prepare the simultaneous equation for this matrix operation. So tomorrow we're going to get into the heart of things after I'll show you that what you should have written tonight for those two, that yes, you can do it, and then to give you the backbone for principle and see how far we are getting. Take our times, because once we learn it, you will never forget it. It's going to serve you up to the second, third, fourth, and fifth generation. That's all there will be for you to learn. So, from us here at ABS Television, Jetta operating this camera, this is Karen Weston saying, do enjoy the rest of the evening and see you tomorrow.
Join us next time for another in the series, Mastering Mathematics, a production of the Education Broadcasting Unit in the Ministry of Education and ABS TV.